Hello everyone, welcome to another video. Today's problem of the day is longest subarray with sum divisible by k. Let's see the problem statement. Given an array ARR containing n integers and a positive integer k, find the length of the longest subarray with the sum of elements divisible by the given value of k. So according to the question, we are given with an array of n integers and we are having a positive integer k. So our job is to find a longest subarray with the sum of elements divisible by k. So if we see the first example, the number of elements given is 6 and the value of k is 3. So if we have to find the subarrays with the sum of elements divisible by k, we can see there are multiple such subarrays. If we add 4 and 5, we got 9, which is divisible by 3, but it might not be a longest one. Again, we can see 7 plus 2 is 9, so it is also divisible by 3, but it is not a longest one. It might not be a longest one. Now if you check these four elements, that is 7, 6, 1, 4, and add all the elements, that is 7 plus 6, 13, 13 plus 1, 14, and 4 is 15. 15 is divisible by k, and so it is the possibly the longest subarray of our given array, which is divisible by the value of k. And so we have to return the length of this subarray, that is 4 in our case, so the output is 4. So in this question we have to handle the negative integers also, that is the calculated sum can also be negative. So let's quickly see how to approach to this problem. So according to me, the whole problem is based on a simple idea. So to understand that, let's take a small example with these four elements. Let's say the array contains these four elements A, B, C, D. So let the sum of these two elements be M, and the sum of all the four elements is N. So can you guess the sum of these two elements? Of course, it will be N minus M. And now if you see, if the value of M is perfectly divided by K, a given value K, and the value of N is also divided by K perfectly, then can we say the value of n minus m is also divided by k? So let's check this with a small example. If we take four elements like 5, 4, 2, and 1, and the value of k in our case, let's say 3. So if we add 5 and 4, we get 9. And if we add all these elements, we will get 9 plus 3 is 12. Here 9 is also divisible by k and 12 is also divisible by k. We are left with n minus m, that is 12 minus 9, which gives us 3, and it is also divisible by k. So by now we are clear with a simple logic. If the sum of these elements is divisible by k, and if the sum of all these elements are also divisible by k, so the sum of n minus m elements will be exactly divisible by k. And similarly, if the sum m leaves a remainder x, and n, that is the sum of all the elements, leaves the same exact remainder while dividing by a certain value, that is k, we can also say that the sum of n minus m elements will also leave a remainder x. So these things are proved. Now we will get back to our example. So in our example, we are given with an array of 6 integers. So according to the logic, we are only working with the remainder and their indexes or the range. And of course, we have to compute the sum of the elements in our array. So let's iterate over the array and calculate the sum of elements. So in first case, or in the first iteration, the sum will be 2. Then we will iterate further and the sum will be 9. And accordingly the sum will keep on increasing. So let us write the sum quickly. 9 plus 6 is 15, 15 plus 1 is then 20 and 25. So these are the sum of all the elements in the array. And now let's find the remainder when these sums are divided by the given value of k, that is 3. So 2 mod 3 is 2, 9 mod 3 is 0, 15 mod 3 is again 0. So here we can see we got a similar remainder. That means this element is perfectly divisible by the value of k. Let us check in the array. We got 6 over here. So 6 is divisible by 3, and it is a subarray of individual element whose sum is divisible by k. So I hope you are getting the logic. Now let's iterate further. In next case, our remainder will be 1. Then 20 modulo 3 is 2. And at last 25 modulo 3 is 1. So in this process, we have seen multiple similar remainders, that is 1 and 1, and also this 2 and 2. So let's check for this case where we got 1 as a similar remainder. So if we see the values of n minus m elements, that is these two elements, 4 and 5. So 4 plus 5 is 9, and we got a subarray whose sum is divisible by 3 exactly. But it is not a longest subarray, hence we can't return 2, the length of this subarray, we can't return that. So let's see another case where we got similar remainder as 2. So the values of n minus m will be starting from 9 till 20, and the elements of the arrays are 7 plus 6 plus 1 plus 4. These are the 4 elements which we got, and if we add up, we got 13 plus 1 14, and 4 is 18, which is also divisible by k. Hence it is the longest subarray whose sum is divisible by k, which is 3. So we will return the length of this subarray, which is 4. So this is all about the logic. At last we have to handle a case where our remainder is negative. So let's say k into a certain number n leaves a remainder r. It might happen that our remainder is negative. So to make it positive for the ease of our solution, we can add plus k, and to balance it we can subtract the k. So if we take k as common, we will get n from here and minus 1 from here, and lastly we are left with these two. So we will get k minus r, and hence we can see if we multiply a number with k, we are getting a positive remainder in this case. So what we have to do is, in the case of negative remainder, we just have to add it by the given value of k. So that much we have to do in our program. Now let's get into the code quickly. So let's take a variable which will store our final result. Int res is equals to 0. Now to store the remainder and the indexes by which we can see whether we have encountered a certain remainder previously or not, we can take a hash map. In the hash map, the key will be the remainder and the indexes will be its values. So let us name it as sum remainder, because we have to divide k with the present sum, equals to new hash map. To calculate the sum of elements in our array, let's take a variable sum, and to calculate the remainder, let's take rem. Now we will run a loop through our array, that is from int I equals to 0 till the range, and I will be increased by 1. And while iterating, we will simply add up all the elements present in our array, and simultaneously we will calculate the remainder also, that is sum modulo k. So by now we are having our sum and our remainder. So in the next step we have to check if the remainder is negative or not. So if we check rem is less than 0, and if it is true, then we have to simply add k with our remainder. So rem plus equals to k. That's it we have to do for the negative cases, and then we will check if our hash map already contains an remainder or not. So if it already contains, that means we got a similar remainder, and hence we got a subarray. So let's quickly write the code for that. If sum remainder dot contains key, and we will pass the remainder value. If it already contains the remainder, so we need to know the index value of the previous remainder where it was equal. So let's store it in a variable index, sum remainder dot get the value of that remainder. So how to calculate the range? We have discussed that, that is n minus m. So the range is equals to the present element, that is I, minus the index where the remainder was found previously. So we have stored that in our index variable. So we will subtract index from I. And now the last condition is we have to return the length of the longest subarray. So for that we have to calculate the longest subarray. So in each case we will check if our range is greater than the result or not. By default we have stored it as 0. So as soon as we got a subarray, even if of one length, we will update our result value. So in that case, when range is greater than res, we will update our res value with the value of range. And now the else part, that means when our hash map do not contains the remainder. So in that case, we will simply put our remainder in the hash map with the value of index. So let's write the code sum remainder dot put, we will add the remainder and the index value, that is I. And at last, after every iteration for the array elements, we will come outside the loop and we will simply return our calculated result value. So this will be our result, and we have declared our hash map, but we have to initiate it with some values. So let's say some remainder dot put. By default it will contain 0 remainder and the index will be -1. Let's say it's the default value. So we can understand this with a quick example again. Like in the first example only, here we got 0 in our second iteration. So by default our hash map contains 0 remainder. So the sum of elements from this index to this index, that is I minus range, will also be divisible by the given value of k, which is 3. So let us check quickly the first two elements, that is 2 and 7. 2 plus 7 is 9, that is exactly divisible by 3. So hence we got our result. So this is our default value of our hash map, and the index will be -1, and the rest of the cases are already being discussed. So let's quickly get back to the code, and we are already done with the code. So let's compile and run our code. So it is compiling fine. Let's submit our code. So our code successfully passed all the given test cases. And now let's talk about the space and time complexity of the program. So the expected time complexity was big of n, and the auxiliary space was also big of n. So we took a hash map which will store the sum of n array elements. Thus the space complexity is clearly big of n. And coming to the time complexity, we have run a loop which will iterate through the given array whose size was n. Thus the time complexity is also big of n. So we have achieved our expected time and space complexity. And that's it for this video. If you have learned anything new from this video, please like, share and subscribe our channel, and let's get back in the next video. Till then, happy coding.